And now let's talk about alcohols and ethers, and we're going to wrap up with this actually. So this will be the last part of the lecture. All right. So alcohols are here characterized by this simple hydroxyl group here, the OH group. Um, Normally that OH group is attached to a carbon chain um, somewhere on the chain, right? And an ether is a little bit different from an alcohol, where this is OH. Notice here the ether has, all right, oxygen as the central atom, and then carbon bound to either side of the oxygen. And then also remember that oxygen has two lone pairs that are here, right? So on the left side of the oxygen there's a carbon group, and on the right side of the oxygen there's a carbon group. So that's an overview for alcohols and ethers. Now let's look at some compounds that contain them. All right, this is THC, tetrahydrocannabinol. It is the principal component in marijuana, the part of the compound or chemical in marijuana that actually makes you feel quote unquote high. And again, if you look here on THC, here is an OH that's typical or indicative of an alcohol, OH, the OH group. And then here is an oxygen with a carbon on the right or the left side and a carbon on the right side. So this is an ether, O carbon, carbon. Alright, this is vitamin E. This is the alpha tocopherol form of vitamin E, the form that the body prefers. And if you look here, you also see two functional groups that one of them is an alcohol here, one is an ether here, right? Again, OH is indicative of the alcohol, and then oxygen with carbon on one side and a carbon on the other side. Notice these are two single bonds, sigma bonds to oxygen. That indicates that functional group is an ether. Alright, so let's try and draw an alcohol. So here, if I just go here and then OH, that's an alcohol. It's primary, right? And if I do this, OH, that's a secondary alcohol, right? Because this carbon here has a carbon on this side and a carbon on this side. So the carbon where the alcohol is bound to has two carbons attached to it, so we call it a secondary alcohol. And then over here, OH, this is what we call a tertiary alcohol, right? The carbon that the OH is bound to has 1, 2, and 3 carbons attached to it. So this central carbon has 3 carbons attached to it, so it's tertiary. Ethers are also very simple. If we take just a simple alkyl chain, here's my oxygen in the middle, connecting the two chains. I have oxygen here, carbon here, and carbon here. And notice this is a single bond. Right, on both sides. Right, so you can practice those when you get some time. Hopefully you'll practice drawing all of your functional groups and understanding what atoms compose those functional groups. And that way, when we get ready to talk about reactivity, we're not stumbling over whether or not what's an alcohol, what's an ether, what's a ketone, what's an amide, what's an aldehyde. We know that already. All right, let's keep going. This is penicillin, and what I want you to do as part of your extra credit is to look at penicillin and pick out all of your functional groups. right? This particular functional group right here is what we call a sulfide. Right? That's a functional group that you don't see a lot, but it's here in penicillin. You can pick the other functional groups out, hopefully, and I'm going to assign that as extra credit. Also, in addition to this as extra credit, I just want to put this here, this codeine and promethazine. You know, a few years ago, this was a really popular drug, especially among rappers out of Houston. Pimp C actually died from a codeine overdose. DJ Screw died from a codeine overdose. Big Mo died from a codeine overdose. So this stuff is not anything to play with. And the reason that it's not is because it's a depressant. It causes drowsiness. It slows your breathing down. Can lead to heart failure. These are some other rappers that have abused codeine, or used codeine, or rapped about codeine, or talked about codeine, or lean, or purple drink, or whatever you want to call it. Okay, so what I want you to do for extra credit is to locate all the functional groups that are present in penicillin. We already talked about that. All the functional groups that are present in promethazine, and all the functional groups that are present in codeine. And promethazine, when you mix it with codeine, you use that to keep from getting an upset stomach. So that's just a little FYI. Okay, so we're going to stop here. That concludes the lecture on functional groups. Go back, rewatch it, practice the drawings, just watch it as many times as you need to. And if you need anything else, you can tweet me questions on Twitter at Kim Russell. The extra credit, don't forget that. I'll take that Monday. And then of course you can email me or drop by my office for office hours. And I hope that you got something out of this presentation, and I'll see you in class. Peace.